The geometry tools in FILOU NC. The geometry tools are found in the Geometry tab. When we click on it, we can see all the tools to load a drawing, to save a drawing, to create geometry, to edit geometry, and so on. Then we have the viewport, this area here. This is the place where all the geometry is displayed and where we can edit it. This is the Object Snaps toolbar. We will use it soon when we start with creating geometry. First, we load the drawing from the samples folder by using the File menu and click on Open Drawing. We can do the same by clicking and holding a button, this one, and release the button over the menu. Now we select the sample.dxf from the samples folder and open it. Now we can see the whole content of the drawing, but first let's talk about the axis. The x-axis is the horizontal direction. It is always in red, and to the right is positive. The y-axis is green, and the positive direction is this direction. To change the view, we can use the mouse wheel. When we set the pointer, the mouse pointer, to, for example, this corner, and we then rotate the mouse wheel, it zooms exactly around this point. That is important, that we always set the pointer to the place where we want to zoom to. For example, this corner, when we rotate the mouse wheel, it zooms exactly around this position. To move the view, we hold the middle mouse button and move the mouse. Like this. We zoom to this circle and we can now move the view. An important function to judge over the drawing is the mark endpoints function. When we activate it, we can see a lot of points. These points are always at the ends of elements. Let's see here, this is a line, this orange line. It has a point here and a point there. This is an arc, also a point here and a point there. This seems to be pretty clean. When we look at this, it does not look so clean. It has a lot of points, which can be okay, but I think it can be easier or more simple. This, I know it was an ellipse that was converted to arcs in order to use it in our program and to make NC code of it. This means if it is an ellipse, then this point and this point may be too much, perhaps not important. Therefore, we have a function, it is called clean drawing. It is this function here. And when we clean the drawing, we have several options. First of all, remove identical elements. This means, for example, if we have a line copied 50 times on the same place, that can easily happen when we use the copy function and do something wrong, then it is not good for making NC programs, because I have 50 possibilities how to move along this line. The function remove identical elements kills all the 49 non-wanted lines. The second option, remove overlaying elements. This is meant for situations like this. I think this part here and this part here are the same, just mirrored. And it is not necessary to have this point. While we are at cleaning the drawing, we can also remove very small elements. I select a minimum length of 0.01 and now I click OK. Let's see what happens. 7 elements were removed. Of course, I don't know which ones were removed because it looks the same as before. But let's see. I was right. This was able to connect and the point vanished here. And also at this point we have combined element. This is only one arc and this is only one arc and this is one arc and this one. And before we had 8. What we see next in this drawing is the different colors. This is black, orange, this is blue, and so on. So where do these colors come from? These colors come from the layers. The layers are found here, and I do not go very deep in detail, but I know Rahmen, this is a frame around the drawing, and the field. Okay, when I leave the layers here, I don't have to click somewhere or something. I just leave it and let's see what we have now. This is not there anymore. This is not important for us because we want to create in C code and not a sheet of paper. But now let's create something. To create something, I need a blank area here, and to do so, I just begin a new drawing. New is here, and I select it, and this drawing was changed. The program asks if I want to save the changes, this time not. So we just click Don't Save, and now we can select a template. In this template is nothing but 4 lines and some layer structure. Okay, when we do so, we have a new, nearly blank area. This frame here, this is a certain size. It is called Dyna4. This means it is 297 in X direction, and in Y it is 210. We don't need these elements to do something. It is just a frame to show in which size we are now. We don't need the elements. This means we can delete them. To delete elements, we use this icon here. It is called Delete Element. And now something new comes up. In the green area, we can see the command we want to use, delete elements, and in the yellow area are some hints. What can we do and how and what should we do? Okay, in this case, we shall select elements. Select elements is done by clicking the elements. If I go near an element and click it, then it is dashed now. This means it is selected. Same in here. 2 elements are selected. They are now part of the selection set, this one. And we can click more, this one and this one. Now we have clicked 4 lines. The 4 lines are in the selection set. And to apply the function delete elements to the selection set, we click apply. Then we don't have anything left. I undo this step to show something else. Zoom a little bit out. Select by click or select by window. Now let's try select by window. Select by window means I drag a rectangle around the geometry, like this. And now I have also 4 elements selected, and if I apply, they are away. Once again undo. The window was from left to right, and now I selected the other way around, from right to left. From right to left there's a difference, you can see it. The red line is dashed, and this means that an element has to cut this line, and it can, of course, be completely in the rectangle. When I release the mouse button now, the upright line and the two horizontals are selected. Now let's say this line, the horizontal here, was not wished to be in the selection set, in this one here. So I can remove it from the selection set. When I click this function, remove from the selection, then I can click an element and it's continuous line type now, and that means that it is not part of the selection set. When I select the option Shift, then I can select it again, it is dashed, that means it's part of the selection set. It is cumbersome to click here or there to add something to the selection or to remove something to the selection. I can use Shift and Control. Shift means add and Control means remove from selection. When I hold Shift on the keyboard, then this becomes bold and means it is activated. This is Shift, then it's part of the selection set, and when I hold Control and click, then it is removed from the selection set. I can also, much easier in our case, select all. Then all what I can see is the selected, and I can apply the selection by right click. Let's do something new. Let's create rectangles, but not with this rectangle function. We want to use lines. We draw some lines until a rectangle is ready. So we select line 2 points. Again, here's the function and here's what we can do. First point. What is the first point? I can enter values here to set the first point. But in our case, it is not important where to begin. I just click into the viewport and select a point where the mouse pointer is. So the first click is done, and if I move the mouse now, I have a line at the cursor. This is the first clicked point. This is important now because this is our reference point. The reference point is the point where these values are related to. That means if I want to create a rectangle with 11 units length, then I want to go in this direction, then I enter in x0 and in y11. So nothing happened because I have to use this entered values. Use. Now it's a bit strange view, so I'll zoom it. Correct. The reference point is now this last clicked point, exactly this one here. And when I want to go 11 to the right, I type 11 in X, and in Y it is 0, and use it. When I want to go to here, I have to type 0 and minus 11, because it goes down. Positive direction is here, negative direction is here. Again, I use this point. I'm lazy. I don't want to type x minus 11 and y 0. I use the object snaps now. And is snapped as an option, and when I go near to the point, like this, then it snaps to the end of the line, and when I click now with the left button, the point is snapped and used. When I move the mouse now, I can create more lines, or I end it by clicking with the right button. Here, for information, line is the current function and next point is what is needed. If I click one time right, it reverts to the first point. Okay, let's create another rectangle. here. A good idea would be to copy this rectangle, but we want a smaller rectangle in a special position. So line is still asked. We can use the reference point again. I don't know where it is now. I can read it, but it is not so useful information now. I set a new reference point. The reference point is set by using the object snaps, and I set this reference point to this lower right corner. This is now my new reference point, and nothing happened. I did not create a point for the line. From this reference point, I want to go 5 to the right and in y0 and use this as the first point of the line. Now I want to go 8 in this direction, but that is a bit cumbersome to always type in coordinates. I can set also constraints, and I want to use now a length constraint, and when I check this and move the mouse, I can see I can move the line only 8 units long, but to somewhere. It is not determined where to go. When I want to make it very clean upright, I have to use this function, ortho, and now I can snap every 45 degrees. And when I'm pleased with the preview, not like this, but like this, then I click left and the point is set. The constraint is still active, 8 units. Then I go to the right, I go down, and I go left. Easy. Now let's check if we have done it right or not. Let's see, there are some dimension tools, not to find. But there are analysis functions, and we can measure the distance now. This is the function, and a first point is asked. Then we select this one, and this is the second point that is asked. And now we have some information. The absolute position of the points, not very interesting, but the distance is interesting. The distance in x is 11. Very okay, that is exactly that what we wanted. No wonder we entered the right coordinates. Let's check the distance between the two rectangles. Same function, measure distance. We select this point and that point, and then we have 5. Very okay. There are several functions for rectangles. This is a rectangle corner to corner. We can enter some values or we can snap 2 points. Let's take this endpoint to that endpoint. Another function, rectangle from corner. From corner means, rectangle from center. From center means that we set a center point and then we can, of course, snap to a point, but we can also enter a length and a width. We can set, for example, 25. No, that was a little bit too much. And use these values. Then we have a rectangle 25 and this is 12. We can also make a rectangle from a bounding box. This means, the selection set comes into the game again. We have to select elements. I select all these elements. And now if I apply the selection, a rectangle encloses the selection exactly. We have several line functions. This one is known. We use it for the rectangles. This is very interesting. Line both sides. Both sides means I have a center point and, interesting, I can only go 8 far away because of the constraint. I uncheck it and then I'm free. Because I have ortho on, I can do it only in 90 and 45 degrees. I want to be free. To be free, I have to uncheck the ortho option. By the way, another method to invoke ortho is not to check it, but to hold the shift button, and this means also ortho. To the circles. Circle center radius, for example, is a function that wants to have a center, and we have selected mid, let's say the mid of this, and now we can enter a radius or a diameter. Let's enter a diameter. The length of the rectangle was 11, let's say 10, then it should go nearly to the ends of the vertical line. Just let's use it. What else can we do with circles? We can use circles diameter. This means 2 points. Stop. Let's start over. I cancel it and use it again. To draw a circle by 2 points, I can, for example, select this one and this and 2. This is useful when I want to have the center of a geometry. Then I can select the center of the circle later. There are also some arc functions like arc, center and end. I do it here. The first point is clicked somewhere, and I can always enter values, but now I do it by mouse free. I press shift to make it straight, and now I click the first point, and I can drag the arc, and with ortho I can set exactly 90 degrees opening angle. Arc 3 points is very good when I have to trace geometry, when I have to make a corner somewhere like this. Interesting is also the parallel element. It is an offset from a given geometry. When we select this tool, I can set the offset, let's say 3. And when I move to an element, like to this arc, and it depends on which side of the arc the mouse is. When I have a preview like this, and then when I click, then we have the offset element ready, and to this side is another possibility. I know one of the rectangles covers parts of the others. This means I have overlaying elements that are not so good for editing geometry and also make trouble when I want to make NC code. But let's remember, we have this clean drawing function and we just click OK. 13 elements were removed, means the drawing is clean again. Good. Equidistant path is another function similar to the offset, but it is an offset along a contour. Equidistant path is the function, the offset distance, same as with a simple offset. Let's select another distance, let's say 2. When I show an element, it shows the preview and the side, and when I click it, all the other elements that fit into the chain are selected and the equidistant path is built. This is a distance of 2 and we have the distance here as well. This is the shortest way for a tool that can move around this now yellow rectangle. But why is the rectangle yellow now? The rectangle is yellow because these elements are locked now. The elements are locked to avoid that they are used once again. It is not always wanted to have them locked, but when doing such an equidistant path, it can't happen that, let's try it. It can't happen that I make exactly the same once again. It just doesn't work. When I want to do some more with the now locked geometry, I have to unlock it. Unlock is this yellow lock symbol. This yellow lock symbol again invokes a selection set. Now I can select this one to unlock it, but it's in the selection set. Now it is not unlocked. It is still yellow. When I unlock these 3 elements and apply the selection, then they have their original color again. That means I can do something with it. For example, deleting it. In this case, we had only 4 locked elements. It was easy to unlock them one by one, but there's also a function to unlock all elements. In principle, this was all about creating geometry. There are some more tools for editing geometry. They are found here. We can trim, fillet, and chamfer elements. Also, we can transform them here by move, copy, rectangular array, and so on. In the next video, we will have a small sketch and we create the geometry directly here in FILOU NC. There's one-dimensional tool that I forgot when we were talking about creating geometry. I'm talking about the create geometry from font now. It's called convert text, and this is a kind of text processor that we can use to type in some text. Lowercase, some text. And we can do some formatting on it. To select something and set another font, for example, let's use this one. We have a size. This size in a text processor, this is meant in points, but for us it is drawing units. Let's select another unit, another size. Let's say 8. 8, and there are some more options. We can talk about that later. Now we don't touch it. Let's just hit OK. OK, it takes a moment, and now I have some geometry at the mouse pointer. Place geometry is the current function now, and I have to select a target point. A target point that I can snap here. Let's just use the end of the arc now. Now the function is not over, it is still at the mouse pointer. Right click to cancel. Okay, then I do it. What I have now is geometry that was created from TrueType fonts. TrueType fonts are the fonts that are installed in Windows, and they are made of splines. Splines are not suitable for NC programming. For NC programming, we always need arcs and lines. And the function we have seen now converts these splines to arcs.